Hello, this is Ian Woolf, producer of Diffusion Science Radio. This show depends on your support. Please make a donation directly with the PayPal button at www.diffusionradio.com or support Diffusion by downloading a free audiobook from audibletrial.com/science or go to diffusionradio.com/support and click on an Amazon link or buy my nano drones.
Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
Planetoid.
I love that word.
Hello and welcome to this special blockchain edition of Diffusion. Sit back and relax while we inject weird and wonderful science directly into your brain. I'm Ian Woolf. On this edition, community citizen science, emerging technologies in the developing world, and self-owning blockchain art. But first up, here's the news. Venus flytraps can count to 5. Researchers at the University of Würzburg in Germany have extended previous research which showed that Venus flytraps could count to 3 when the trigger hairs inside the traps are stimulated by an insect moving around to save the plant wasting energy. If the hairs are touched only once, then it may be wind or rain, but the plant gets ready to close. Twice within 15 to 20 seconds, and it's worth the energy expenditure to snap the trap shut quickly. At this point, the traps don't close all the way, they leave enough space that small insects like ants, that aren't worth the plant's trouble, can escape past the trap's interlocking teeth-like spines. In the new study, project leader Rainer Hedrick used a machine that simulated trigger hair touches with electrical signals to the traps of the plant. He found that the plant keeps counting after it closes. The third touch means a larger insect like a fly is struggling, so it closes the trap tighter, sealing it. If the prey escapes because it's too strong or too big, then there are no more touches. The trap will eventually open again. A fourth touch and the plant produces the feeding hormone jasmonate. On the fifth touch, digestive enzymes are released that dissolve the soft parts of the insect and allow the plant to absorb the nutrients. Dinner time! The paper was titled, "The Venus flytrap, Dionea muscipula, counts prey-induced action potentials to induce sodium uptake," and was published in the journal Current Biology. Blockchains are the technology behind Bitcoin. Blockchains are a way of using the mathematics of cryptography to make trustworthy transactions on a publicly available record that can't easily be fudged, without having any kind of middleman. Whether your middleman is keeping the books, or taking your money and then making a payment for you, or recording your vote, or any number of other parts of civilization where a trusted middleman has been needed. Middlemen are a problem not only because they charge a fee by taking a cut of every transaction they're in the middle of, but because you usually can't tell straight away that they've betrayed your trust by stealing more than you agreed as a fee, or having deliberately fudged the books about what happened, or whether a criminal has broken into the middleman's position and is stealing or fudging without the middleman noticing. For example, when fans of WikiLeaks tried to make donations using credit cards or bank transfers, the banks took their money but then refused to pay the money to WikiLeaks. The company processing the donations to WikiLeaks successfully sued the credit card companies. The credit card companies had to pay a $5 million fine and pass the donations on to WikiLeaks. It doesn't help that the banks seem to have been directed illegally by the US and UK governments to steal people's money in exactly this way. Banks have this power because they control 95% of online payments. This monopoly has meant that they were too big to fail during the crimes of the global financial crisis. This meant when even as a business in a free market the banks make poor decisions, instead of failing like they should, they were propped up with free money from the same taxpayers they were kicking out of their homes. The global financial crisis itself was caused by middlemen, falsely classifying bad investments as good investments. The LIBOR scandal was London banks fudging the interest rates that banks around the world used as their trusted base for investment and loan rates, distorting world economies. The Australian Stock Exchange and the American Nasdaq Stock Exchange have recently announced that they will be using blockchain technology to introduce mathematically validated transactions and trusted records. Recording transactions on the blockchain lets you replace the middleman with a computer record that's protected by the mathematics of strong cryptography, instead of the monopoly of banks. Avoiding corruptible middlemen can avoid economic crashes like the global financial crisis. Unusually, blockchains and Bitcoin were invented by an unknown mathematician who posted a paper to a cryptography blog calling himself by the pseudonym Satoshi Nakamoto. Like a masked superhero. The governments of the world have been trying to hunt him down. In 2014, Newsweek outed somebody they identified as the real Satoshi Nakamoto. Bitcoin experts laughed at them. In December 2015, the Australian Tax Office ordered the federal police to raid the house of a man they identified as the real Satoshi Nakamoto. And again, the Bitcoin world laughed at them. Every time a transaction happens on the blockchain, software run on all the computers who are using the services of that blockchain make a record, peer-to-peer. They also contribute some computing power towards mathematically validating the transactions and records. People who run Bitcoin mining computers, or their equivalent in other blockchain systems, donate a lot of computing power to publicly validating as many transactions and records as they can. Their validation is on the blockchain record, so any dishonesty will be caught by other people running validation mining software. They get rewarded with free Bitcoin, or in free services from other blockchains. This way, there's no centralized validation unless someone with giant resources, like perhaps the NSA, decided to spend outrageous amounts of money on very fast computers, very big storage farms, and start doing more than half the validation in the world. Hopefully, we're a long way away from that danger. The blockchain is a programmable entity. It's Turing complete. This means you can also run programs on blockchains, and this is the basis of the Ethereum blockchain. It's a giant, massively parallel supercomputer running on thousands of computers and phones around the world. You can also put the programming into smart contracts, so that legal contracts are on the publicly validated record and anyone can see if they've been changed or breached. With smart contracts, you need fewer lawyers and fewer company executives. You can almost have a company run itself without any people at the top. People have been speculating about self-driving cars that own themselves in their automated smart contracted company. If they don't get enough business to pay for repairs and upgrade and recharging, then they go out of business and deliver themselves for recycling. Of course, then you have to establish liability for accidents. Solar-powered houses could distribute electricity in the local community with smart contracts, running a smart electricity grid, all using blockchains. Last year, I won free tickets from UTS alumni to the Sydney 2015 blockchain workshops. I'll put links to the videos on diffusionradio.com. Lawrence Lessig talked about how blockchains could be a huge weapon in the fight against corruption in democracies, but warned that it could get co-opted by the powers that be in the same way that the internet's potential for a free society was turned into a surveillance machine. One of the blockchain workshop organisers is legal researcher Primavera de Filippi. She talked about the blockchain art she created called Plantoid. Plantoid is an automated kinetic sculpture of a flowering plant, self-owning and self-financing art. If you pay it some Bitcoin, it will sing and dance for you. The blockchain records your identity. When it has accumulated enough money, the Plantoid polls all of the people in its record who donated and asks their opinion on new and different features in its physical and software design. These are collated and an engineer is hired to build a new child Plantoid, with excess money going back to the parent Plantoids and the original artists, in a pyramid scheme, since many people have accused Bitcoin of being a pyramid scheme. Primavera created Plantoid along with David Boville, Vincent Rodol, and Sarah Renault. Primavera did agree to be interviewed, but unfortunately we had a communications glitch and it didn't happen. You're listening to Ian Woolf on Diffusion Science Radio. Send emails to science@diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on www.diffusionradio.com.
I figured it out. I figured it out. With a pencil and a pad, I figured it out.
I figured it out.
She figured it out. She figured it out.
I figured it out.
I met Clement Epie while he was giving a talk at the Sydney Biohackers and also while he was an organiser at the Sydney 2015 blockchain workshops. Clement is co-founder of Cellabz, working to apply blockchain technology with emerging technology to develop decentralised labs. With La Paillaise, he's been involved in community open source citizen science, drone building, biohacking, textiles, community makerspaces, and even do-it-yourself space exploration. I began by asking him, what is La Paillaise?
So La Paillaise is a biohacker space that was started almost 4 years ago by a group of hacker, designer, artists. And over the years, they've been moving from a small space outside of Paris, now in a bigger one in the center. And they are bringing open source biotechnology to the communities for people to have a lab where they can do prototyping, trying to develop projects in a community and open way. And slowly we've been welcoming other disciplines from drones with the Fly Lab of Hakim, people in textile like Alice. Mark has been working on space exploration, and many more projects. And so, yeah.
There's an awful lot there. You mentioned do-it-yourself space exploration. So can you tell me about one of those projects?
Sure. So at the lab in La Paillaise, Mark worked for a program that was financed by NASA and DARPA, which was called Space Gambit. And so he's been working with a group of other people, engineers, among them to build what we call a zero-G bioreactor. So basically it's some kind of 3D printer, but instead of using it for printing a plastic object, as we see usually, they try to put into some controlled condition bacteria, algae, and this kind of stuff. So you can have a growing culture, and you can use it, let's say, later for creating biocarburant, food, or any kind of other application. And so the game here was to develop the technology that could work in zero gravity, so on board, for example, the ISS, and also to have a way to publish, to share the data open source, so other hackerspace and makerspace of the world will be able to use the data and push it forward.
Would you like to talk about the blockchain work?
So, okay, I'll give a quick intro. So, blockchain is the underlying technology that Bitcoin is working on. So, Bitcoin is what we call a cryptocurrency. And simple way to say it is that it's like money, a digital money, that doesn't require a bank or a central authority to manage the exchange of the money between different people. And so, over the last 2 or 3 years, we had people who tried to apply the technology outside of the financial sector only. And so we have a group of people, among them Matan, that started back then in Tel Aviv and Spain, a program where where they were trying to pretty much do what Uber is doing, but without a company in the middle. And now they are building a backfeed, which is trying to build the tools that a program like Lazuz would need to be able to fully run on the blockchain and this kind of new technology.
You were talking about sharing rides.
Yeah. So what they are trying to do with Lazuz basically is that the people who provide the car sharing and the person who use it as a consumer are both, because of the exchange, will be part of a fraction of the transaction that will be used to run the system. So right now the way it works is that you have a company, let's say Uber, who have their own infrastructure, their own server, they do all the management of the information, the matchmaking and everything. The idea is to be able to do it on their own without a company in the middle. The people who provide the service and use it are being part of, once again, running the system, but also they need to open the possibility to have new way of doing organization and companies. And so one other thing that this group and others are trying to look at are what we call DAO, for Decentralized Autonomous Organization. And the idea is at some point you'll be able to have companies who can run by themselves by using a smart contract and a few other technology that are related to the blockchain ecosystem. So BitNation is also a blockchain technology project, and their purpose is to tackle the problem of identification. So without going into too much technical, what they are doing pretty much is trying to build an ID card or passport that doesn't need to be produced by a government, and also can be used for doing a lot of service that would be needed with this kind of new technology without once again needed a trust party in the middle. So Big Congress is another of the cool projects that are trying to apply this kind of technology to have a distributed way of doing voting for politics, for example. And so the idea is that instead of having a government that have to check all the voting, recounting, and with some time with the corruption or just error, the idea is that each people who are voting are also checking the votes of each other. So at the end, you have a completely horizontal way of doing these kind of things. So basically what they are trying to do is to have a way to do voting without a third party tampering with the data. And NetSoc is pretty cool. So NetSoc was started by David Orban, and now it's a group of people from all over the world. And what we are trying to do is to see how a decentralized approach can be applied for different industries. So either politics, transportation, health, security, etc. And it was started at inside of the community of Singularity University, and the community will be doing some announcements in the next few months about some interesting project.
You're talking about getting community spaces, startups, universities, and companies all working together with blockchain collaboration.
So, even before using blockchain technology, the thing is that from the work we are doing at Cellabz with all these kind of different organizations and labs, there is a big inefficiency for them to collaborate with each other, and when they can, to be able to push the project to something concrete and tangible. So what we've been doing over the last year or so, and before that with La Paillaise and before that with other projects, is how can we help this kind of organization to collaborate with each other? And one of the theory that we are trying to implement is that by allowing traceability of the contribution of people into projects, by allowing cheaper and almost automatic juridical system between the different party with what we call smart contract, by applying incentive with a microfinancement like you would do with a mechanism like Bitcoin and cryptocurrency. When you combine these kind of things together, plus knowing who is doing what, how it could be applied together to build to the next step. So pretty much it's the theory, the concept of you build on the top of your parents' shoulder. The idea is that by applying this kind of tech, you would have another way of organizing the collaboration, which at the moment with the current technology, the organizational technology that we have, it's not really easy or even feasible.
And lastly, you mentioned nanosats. Satellite imagery with little tiny satellites?
Yep, so you have some really cool company in the space environment blooming for the last few years now. And one of them is called Cellabz, was started by Will and his partners. And what they did was they used off-the-shelf technology back then, and the Android phone, for example. They put it on a rocket, they sent it in a Black Rock Desert. The thing crashed, but they were able to collect the data. And the demonstration was to make that you could develop low-cost satellite technology. And so since then they have a few hundred, so they have more than 100 nanosat in orbit. They are doing space imagery to a 3 to 5 meters resolution. The project is open source, so the data they are producing, minus a few for security reasons, are being published. They have a platform that people can use, and the business model is for them to use this data, which at some point very quickly we will have a full coverage of the Earth being refreshed very rapidly, and will be for people to imagine new service that can be built on top of it.
Clement, thank you very much.
Thank you.
Also at the Sydney Blockchain Workshops, I met Kasek Gulgul. He's an academic at the University of Papua New Guinea who also researches emerging internet technology and the benefits they could have for developing communities. I began by asking him, did he think blockchains were a technology that will make a difference in developing economies?
Definitely, it'll make a lot of difference. It's just how we take it from here, and in order to make the most positive outcome from this.
So what aspects of the technology do you think will be the most important?
I think the security and it's building trust around the community, because that'll definitely lead to greater usage of the technology. And in particular with blockchain, it's just the more users, the better, the more secure.
So what is it about the blockchain that will make people trust it more, do you think, or get more of the users in?
Well, it's based on certain concepts of cryptography, which would take an hour if we were to explain it. But yeah, it's just, we've all heard of Bitcoin, and it's just a method of verifying certain payments, or doesn't have to be payments. That's one example of it, the financial side of things. Verifying contracts, that's another example of how blockchain can be what they call smart contracts. And also, in particular, for example, in developing economies, one example is in Honduras, where they use blockchain as a method of resolving land disputes. Yeah, so what a blockchain is just a sort of, it can be, in the case of cryptocurrencies like Bitcoin, you have a public ledger and you have a whole community that verify the truth of a certain transaction. And if they all can, it's decentralized, so there's not one particular entity that is controlling the whole thing.
So is there an aspect of this that you'll be taking back to try and work on?
Yes, definitely. The particular aspect would probably be just the applications that people have been using blockchains in certain different applications. And as is the case with most conferences, the biggest thing that you gain from is that the people you meet and the connections you make, and and that'll definitely help in some of the projects that would.
Were there any applications that really stood out as just being amazing, that really impressed you?
Yeah, there was an application on corruption, how blockchains can be used to eliminate corruption, because if blockchains in place, they can ensure due process. And that's one of it becomes a bit of an elephant in the room sometimes. You can't really discuss it, but that's one of the main applications that could actually take off.
More generally, what are some of the other emerging technologies that you've been examining lately?
Internet access is a main issue, and just one thing, just bringing the costs down. Costs is sometimes a big barrier, and just establishing in emerging economies the use of IXPs and peering in order to bring content locally and make it more cheaper for people to access and actually fully utilize the potential that the internet has to benefit them.
Do you think the new cheaper little computers like the Raspberry Pi might sort of help in that area?
Yes, definitely, because that makes information and makes computing more available, more accessible to communities that would have never been able to access such previously.
Is that sort of technology getting into the developing world?
There is a lot of work to be done, and you would like the penetration to be a lot faster, but yeah, there is a bit of work to be done, and that probably needs a lot of education, and people in the right places need to be aware of what is happening and what's in certain places. It's easy for us sitting here and saying that these people should be doing this and we should be moving this way, but maybe they're not as aware of what is happening in our space. So that would be one important thing to. Yeah. No, that's. I think it was just the blockchain workshop was excellent, and there'll be a lot of documents that will be coming out, and they'll all be released under Creative Commons license, and hopefully things can branch off and build up from there.
Terrific. Kasek Gulgul, thank you very much.
Thank you.
Thank you to Clement Epie and Kasek Gulgul. And that's all from us this week on Diffusion. Would you like to join us? We need more people contributing stories to Diffusion. You can send your contributions, opinions, congratulations, standing ovations, helpful suggestions and donations to science@diffusionradio.com. That's science@diffusionradio.com. Please do send me an email so I know you're listening and you'd like to hear more episodes. Please like the Diffusion Science Radio page on Facebook and rate us on iTunes. Tell your friends, follow me on Twitter @Ian Woolf. Checking production was Charles Willock. I produce Diffusion, which is broadcast around Australia on the Community Radio Network, including 2HHH in Hornsby Ku-ring-gai, 2MVR in Nambucca Valley, 2XX in Canberra, and 3MBR in the Mallee Border districts of Victoria and South Australia. Diffusion is syndicated globally on the National Science Foundation's Science 360 internet radio station and also on astronomy.fm. Subscribe to our podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com, and check the website for links, photos and videos about this week's show. If you enjoyed the show, then explore more than 700 previous episodes archived on diffusionradio.com, where the shows are labelled by keywords, so you can focus in on the stories you want to hear. Subscribe to the Diffusion YouTube channel at youtube.com/c/diffusionradio. I'm Ian Woolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science